In commercial electrical installations, several key code requirements dictate proper wiring practices. Firstly, concerning wires and drop ceilings, the code explicitly states that wires cannot be laid directly on ceiling tiles. Instead, they must be securely fastened to the roof structure or supported by other approved means. This requirement is outlined in NFPA 70 section 300.22c3. Secondly, when running wires between floors, the code mandates that wires passing through holes in floors must be protected by a sleeve or another approved method. This protects the wires from physical damage and helps prevent the spread of fire and smoke. This is addressed in NFPA 70 section 300.21b. The use of fire caulk is a good practice, but the sleeve is the primary requirement. Thirdly, all wiring, including low voltage wiring, must be enclosed in conduit, cable tray, or other approved raceways to a height of at least 7 feet. This requirement applies universally, including in telephone rooms and HVAC rooms. This is found in NFPA 70 section 300.22b. However, there are exceptions to this rule. Exposed wiring is permitted in specific instances, such as wiring within equipment or machinery. Also, low-voltage wiring for lighting fixtures connected by flexible cords is an exception, and low-voltage wiring for remote control or signaling devices may be permitted to be exposed. These exceptions require careful attention to ensure proper installation and protection to maintain safety and code compliance. It's important to consult the specific edition of the National Electrical Code, or NFPA 70, that is enforced by the authority having jurisdiction, which is often abbreviated as AHJ. The AHJ is the entity responsible for enforcing electrical codes and standards, such as a local building inspector or electrical inspector. They have the final say on whether an installation meets code requirements. To ensure code compliance, one should consult the specific sections of the NEC, including, but not limited to, sections 300.22c3, 300.21b, and 300.22b. These sections cover wiring in ducts, plenums, and other environmental airspaces, protection against physical damage, and wiring methods for specific locations. When selecting wiring methods, consider the environment. For example, in wet locations, use conductors and raceways approved for wet locations. In corrosive environments, use corrosion-resistant materials. Pay attention to ampacity dirting factors. When multiple current-carrying conductors are bundled together, their ampacity must be derated according to NEC Table 310.15 Kern. Ensure that the wire size is adequate for the load and the installation conditions. Grounding and bonding are critical for electrical safety. Ensure that all metal enclosures, raceways, and equipment are properly grounded and bonded to provide a low impedance path for fault currents. Use appropriate grounding and bonding methods as specified in NEC Article 250. Consider the voltage drop in long wire runs. Excessive voltage drop can cause equipment malfunction and inefficiency. Calculate the voltage drop using appropriate formulas and ensure that it does not exceed the maximum allowable voltage drop as specified in the NEC. For example, for branch circuits, the voltage drop should not exceed 3% and the total voltage drop to the farthest point in the circuit should not exceed 5%. When installing wiring in suspended ceilings, support the wiring independently of the ceiling grid. Use cable supports, such as J-hooks or cable ties, to secure the wiring to the building structure. Do not lay cables directly on the ceiling tiles, as this is not permitted by the NEC as we already mentioned. When penetrating fire-rated walls or floors, use approved fire-stop materials to maintain the integrity of the fire-rated assembly. Fire-stop material should be listed and labeled for the specific type of penetration and the fire resistance rating of the assembly. Follow the manufacturer's instructions for installation. When installing wiring in hazardous locations, such as areas containing flammable gases or vapors, use wiring methods and equipment approved for hazardous locations. These include explosion-proof conduit, fittings, and enclosures. Consult NEC Article 500 for specific requirements for hazardous locations. When working with electrical systems, always follow safe work practices. To energize circuits before working on them, use appropriate personal protective equipment (PPE) and follow lockout/tagout procedures to prevent accidental energization. Only qualified electricians should perform electrical work. Conduct regular inspections and maintenance of electrical systems to identify and correct any potential hazards. This includes checking for loose connections, damaged insulation, and overloaded circuits. Keep accurate records of all electrical work performed, including wiring diagrams, equipment specifications, and inspection reports. This information can be helpful for troubleshooting and future maintenance. The NEC provides specific requirements for different types of wiring methods, such as rigid metal conduit (RMC), electrical metallic tubing (EMT), flexible metal conduit (FMC), and cable wiring. Choose the appropriate wiring method based on the application, the environment, and the NEC requirements. For example, RMC is suitable for use in wet locations and areas subject to physical damage, while EMT is suitable for use in dry locations where physical protection is not required. When installing cable wiring, such as non-metallic sheathed cable, NM cable, or armored cable, AC cable, follow the NEC requirements for support, protection, and bending radius. Secure cables at intervals specified in the NEC, protect them from physical damage, and avoid exceeding the minimum bending radius. When terminating wires at electrical equipment, such as receptacles, switches, and circuit breakers, use appropriate connectors and terminals. Ensure that the wires are properly sized for the terminals and that the connections are tight and secure. Follow the manufacturer's instructions for terminating wires. When installing electrical equipment, such as panel boards, transformers, and generators, follow the NEC requirements for clearances, ventilation, and accessibility. Provide adequate space around the equipment for maintenance and inspection. Ensure that the equipment is properly ventilated to prevent overheating, and provide clear access to the equipment for qualified personnel. The NEC includes specific requirements for electrical systems in healthcare facilities, such as hospitals, nursing homes, and clinics. These requirements are designed to ensure the safety and reliability of electrical systems in these critical environments. Consult NEC Article 517 for specific requirements for healthcare facilities. The NEC includes specific requirements for emergency power systems such as generators and uninterruptible power supplies (UPS). These systems are designed to provide backup power in the event of a power outage. Consult NEC Article 700 for specific requirements for emergency power systems. The NEC includes specific requirements for fire alarm systems. These systems are designed to detect fires and alert occupants of a building. Consult NEC Article 760 for specific requirements for fire alarm systems. The NEC includes specific requirements for communication systems such as telephone, data, and cable television systems. Consult NEC Article 800 for specific requirements for communication systems. The NEC is a comprehensive document that covers a wide range of electrical topics. It is essential for electricians, electrical engineers, and other professionals in the electrical industry to be familiar with the NEC and to follow its requirements to ensure the safety and reliability of electrical systems. To clarify some additional points, consider the use of appropriate junction boxes. All electrical connections must be made inside approved junction boxes or enclosures. These boxes provide protection for the connections and prevent accidental contact with live wires. The junction boxes must be accessible for inspection and maintenance. Consider also the proper labeling of circuits. Clearly label all circuits and panel boards and disconnect switches to indicate the equipment or area that they serve. This helps to prevent confusion and errors during maintenance and troubleshooting. Use permanent labels that are resistant to fading and damage. When installing wiring in concrete or masonry walls, use approved wiring methods, such as conduit or embedded wiring. Protect the wiring from physical damage and moisture. Follow the NEC requirements for minimum cover depths for embedded wiring. Additionally, consider the coordination with other trades. Coordinate electrical work with other trades, such as HVAC, plumbing, and carpentry to avoid conflicts and ensure that the electrical system is properly integrated with the building. Review the building plans and specifications to identify potential conflicts and coordinate the work accordingly. When performing electrical work, always use the correct tools and equipment. Use insulated tools to protect against electric shock. Use appropriate testing equipment to verify that circuits are de-energized and to check for faults. Maintain the tools and equipment in good condition. Furthermore, think about the proper disposal of electrical waste. Dispose of electrical waste, such as used wire, circuit breakers, and lamps, in accordance with local regulations. Do not dispose of electrical waste in the regular trash. Recycle materials whenever possible. Another important point is arc fault circuit interrupters. Arc fault circuit interrupters, or size, are required in many areas of a dwelling unit to protect against electrical fires caused by arc faults. Install a size in accordance with the NEC requirements. Test the size regularly to ensure that they are functioning properly. Ground fault circuit interrupters are also important. Ground fault circuit interrupters, or GFCIs, are required in wet locations such as bathrooms, kitchens, and outdoor areas to protect against electric shock. Install GFCIs in accordance with the NEC requirements. Test the GFCIs regularly to ensure that they are functioning properly. Surge protection is another thing to consider. Protect sensitive electronic equipment from voltage surges by installing surge protective devices, or SPDs, at the service entrance and at individual equipment locations. Select SPD with appropriate voltage and current ratings. Regularly inspect the SPD to ensure that they are functioning properly. Remember the importance of energy efficiency. Design electrical systems to be energy efficient by using energy-efficient lighting, equipment, and controls. Consider using occupancy sensors, daylight sensors, and dimming controls to reduce energy consumption. Follow the NEC requirements for energy efficiency. Think about future expansion. Plan for future expansion of the electrical system by providing adequate capacity in panel boards, conduits, and wiring. Consider the potential for future loads and provide spare circuits and raceways. This will make it easier to add new equipment and circuits in the future. The NEC is updated every 3 years, so it is important to stay current with the latest edition. Attend training courses, read industry publications, and consult with experienced electricians to stay informed about changes to the NEC. Use the most current edition of the NEC when designing and installing electrical systems. There are also state and local amendments to the NEC. Be aware of any state or local amendments to the NEC that may apply in your area. These amendments may add or modify the NEC requirements. Consult with the local authority having jurisdiction or urge to determine which amendments apply. It is always good to remember that safety is the top priority. Always put safety first when working with electrical systems. Follow safe work practices, use appropriate personal protective equipment, and comply with all applicable codes and standards. Never take shortcuts or compromise safety for the sake of convenience or cost.